So can you give a brief interview about like who you are, like what you're interviewing for, how much experience you have, how much lead code have you done, stuff like that, and then we can get started. Got it. Yeah, it sounds good. Definite problem people have, and I do recommend doing mocks to get the nerves out of the way. So, okay, so I'm gonna give you a problem up here, and you can feel free to ask anything you want to. So in the first problem, you're going to be given an array called nums. So let me give you an example. Let's say we have this, and this array is one indexed. So one indexed. So the index would be like 1, 2, 3, 4, 5. And basically what you can do is for any number or for any index in 1 to the length of nums over 2, you can swap the num at, so let's call this index I. You can swap the num at index I and I times 2. You can do this as much as you want. Okay, and basically what I want to know is at the end, can this array be sorted doing this? So just to give you an example for this first one I gave you. So for this first one, it's almost sorted, except for this 4 and this 2 are in different slots. But because, you know, for index 2, I times 2 would be 4, you can do the swap here. So you would basically just swap index 2 and index 4, and then you would get 1, 2, 3, 4, 5. So this case would be yes. And let me give you another example. So we have 1, 2, 4, 3, 5. So in this case, once again, if I write out the indices here, 1, 2, 5. So here I need the 4 to go here, but there's no way I can do anything because I can't swap 3 with anything. So in this case, this would be no. And feel free to ask anything you want to.
Code nums, and my target is to let this array to be sorted in increasing order. Right. Yeah, and I can do multiple operation that swap the nums at index I and I multiply by 2. And for this example, I can swap index 2 and 2 multiplied 2 is 4. So I can swap index 2 and index 4 so that the array will be sorted. So this example will return true. And the second example will return false because these two index cannot be swapped.
Yes.
Yeah. Okay. So I think I understand the question now. So let me think. I think because we have an array, right? We have an integer array, so we can, like, let me copy this example. We can, like, we can build another sorted array. Like, if I have sorted array, go 1, 2, 3, 4, 5.
Oh, by the way, so I forgot to give you one piece of information that's actually going to help you. So the other piece of information is this array is a permutation. Forgot about that. Of n. Meaning, like here, where n is the length of where n is length of nums. So basically, like here, we had 5 nums, so it's always going to be a permutation of whatever num. So you'll always have 1 to the length of the array in some random order.
Okay. So because we are okay. This is a permutation of reunion. So every number is a different number, right?
Yes.
Every number, yeah. Okay. Okay. So let me nouns have different numbers. Yeah. So okay. So yeah. Let me continue. Yeah. So so I can build it build another sorted array that is sorted in ascending order, and we can also keep the index. Sorry, the index is 1, 1, 2, 3, 4, 5, and the index here is this is the original index, and the sorted pair is like 1, 4, 3, 2, and 5. So sorry, 1, 4, yeah, 1, 4, 3, 2, and 5. And I think when I have the sorted array, and I can check, like like build another sorted array with a pair like the number and its index. And when I have this, and I can like iterate the sorted array from left to right, and if the index is the same, if the index is the same as the value, we can skip. We know this is already a sorted index. And if it is not, for this example, if it is not, and this is 4, which should be 2. So we have to check, and sorry, we have to check if sorry, let me think. The value should be 2, and the final value should be 2, and the current index is 4. So this means we have to web from left to right, and we know the index is 4, and the original index should be 2. 1, 2, 3, 4, 5. The original should be 2. So we have to check if the original index here, its value is 4. If that is, which means we can swap these two values, so that so that it will be the sorted value will be placed to this index. 1, 2, 3, 4, 5. The x is 4, and so let me I think I should write, this is the original index, original index, and this is the, like, maybe this is a new index. Original index, new index. No, the original index should be this, and the new index. This is the new index is just the array index. It's just the array index, and the original index is like this pair of, and when we see that multiply 2. So when we iterate the sorted array from left to right, we know the its original index is not the index that we it's not the original index is not the new index, which means we must do an operation at this index. And how do we do this? It's like we have to swap the index. For example, we have to swap the index 4 because we know the original is index 4, so we have to swap the 4 and swap the 4 to swap our original index 4 to a new index 2, and we can check if the original index 4 divided by 2, or we have to check if swap is valid. It's we have to check the swap is valid, and if that is the case, we can we know this index this value can be swapped. The value 2 can be swapped to this index.
Yep. So how would we do that? Like we know it's like at 4, it needs to go to 2. How would we check if it's valid?
Yeah. Let me think. Because we know when we when we add index 2, we have the information we have is we have these 3 information. The first 2 is our pair with the sorted array, and the third is the new index, which is just the index in this sorted array. And at this point, we know that we have to find the index 4 in the original array. Like here, we know we have to find, we can search the index 4. We can search the index 4 here in the original array here, and find the value here, and we know that this value is 2, and we can check that because nouns have different numbers, no duplicate numbers. So when we know that this value is 2, and we can check that if the value is equal to the new index. If it is, then we can swap. We can swap.
If the value is equal to the new index. Well, okay. So that just basically tells you if it can go there. But what if you had this case, right? Let's say you had 1, 4, 2, 3, 5. So like here, this thing would need to go at index 3, so the value would be equal to this index, but you can't move it, right?
Yeah,
so you
yeah,
have this constraint of like you can only swap indices that one is, the second one times 2.
yeah,
So how do we ensure that we handle that case where like in this example, you can't move the 3 because it's at index 4 and you need to move it to index 3.
yeah,
Where in the previous one, you could. Like, this is movable. But if you just check, like, oh, it's here, then I can move it, like, that's not enough. You need to figure out, like, how do I make sure that these indices follow this rule?
yeah, yeah, yeah.
Yeah.
Yeah, I think because we can swap index, we can swap index I, and I multiplied by 2. I think this which means we can swap I minus 2 and I minus 2 minus 2, I minus 4 and I minus 8
Mm-hmm.
and I minus 2 power of for example power of k. So
Mm-hmm.
so maybe this this value can be we can have a group. We can group this this value like the index I. I think maybe take this for example. Take this for example again. That we can group the index, like index 1 and the index 1 multiplied by 2, 3, and 3 multiplied by
So
2
index
is
1 by 2 would be 2, not 3.
oh sorry, yeah, 1, 2, and 4.
Mm-hmm.
We can group this because we guarantee that we can just swap this 3 index. We don't have the limitation to our swap operation, so we can basically we can just swap as many times as possible as we want.
Mm-hmm.
So we group the 3 index 1, 2, 4, and then we can group another starting from maybe 3 and another group that is 5.
Mm-hmm.
Right. So we can just check each group if that can be sorted as their new index, because this is a permutation of an right. So let's say the group 1, this group 2, the group 2 just have one value, and the group 3 just have one value too, and the group 1 just the group we just check the group 1, the index 1, if its value if that can be if the value can be 1, 2, 4, the value can they can their value be sorted to 1, 2, 4, and and can their value be sorted to 3, and can their value to be sorted to 5? If we can guarantee all the group, then I think the array can be sorted in ascending order.
Oh, I see. So you're gonna create these groups. You're gonna sort each of these groups, and then you're gonna verify that these things are correct, right? So for group 1, you'd basically take the value at 1, 3, and 1, 2, and 4, and you'd see
Yeah.
like, does this equal this? And for 3,
Yeah.
it has to. Okay, I see. Got it.
Yeah,
So you're like splitting it up into groups, and then for every group, you're verifying that it's sorted to the right thing. Yeah, it makes sense. What's the time complexity and space for that?
Yeah, I think the time complexity is because we have to build another array. We have to scan the array.
Mhm.
For example, the worst case is like we I think maybe it's just briefly O n log n,
Okay.
because we need to sort the array. We need to sort each group, and each group, the size of each group should be not really large, but the exact number I cannot give right now. Yeah.
Okay.
So
Yeah, sounds
let's
good.
say that's n log n, and the space I think is because we need another sorted array, and we need to no, we need to build our group, so it's like on.
Okay. Yeah, I think this sounds good. Do you want to code it?
Yeah, can I code now?
Yeah. Yeah.
Yeah, okay, let me try. Okay, so I code I write can I write down code here, or do
I
you
would
want
make
me
a
to?
function. You're not running
Yeah,
it, so just make a function, and then we can pretend you called it. So you can get rid of the main. You can make a function, whatever. Just like make a function that will do all this.
yeah, okay,
So
so
function that takes
that
an input of what did I say? N, right? So function that takes an array, and then the rest of it. Yeah.
yeah, okay, so let's say we have the function let's check array can be sorted,
That's fine.
and the return type is a Boolean variable,
Mhm.
and we have our input is a number array.
Mhm.
So we have a vector, and we call it nonce is a number array. So that's our function signature. Is it okay?
Yeah.
Just call this. Yeah, okay. So I think I will. I think. Okay, so I think I can. I think because we need to build our group, right? So I think okay. So I will write. Let's say we have our the size of our the array, and we have to like we have to start. For example, if we start from the first index, and we have to gather each index multiplied by 2, and then if and then this is the group, and for next time, for example, here the first time we do, like we have a for loop. The first time we start from here, this is our I,
Mhm.
and 1 2 and the 4 here, this is
Mhm.
first time, and the second time is like we the second time we know that we are here, we are at the index 2, but we have to like we have to use another like hash set to mark our index, hash set used to mark the used index in the previous for loop, so that we will not check the send index again. So this is the first for loop, and after the first for loop, we mark the index 1 2 4 here, and the second for loop, the for loop here, index I is 2, and we know the index 2 is in our use array, so we will skip this index, and until we find the group, the start index of the group, so that we will not we will not we will not iterate the same group multiple times.
Cool.
I think we need another used array, a
Yep.
hash set, to skip this duplicate things.
Yeah, it makes sense.
Yeah. Okay. So uh, let me let me. Okay. So can let me write the code now. Okay.
Yep.
Is it okay?
Yeah.
Okay. Okay. Unordered set. Oh, we call this used array. And I think we start from because the array is one index, but in programming language the starting index is 0. So let's assume we start with 0, and I will, like the actual index, I will +1, so that
Sure.
we will not missing the our definition for the index for the question.
Yeah, sounds good.
So yeah, and we start from here, and we have to build our array. So that's build our group. So the group is the group is just like a vector here, and in here we can just write another for loop that gather our group. So here I say index equals to I. Index equals to I plus 1. Let's say index equals index should be smaller than equal to n, and the index multiplied by 2 here. Yeah, and we can just push back the numbers index -1. This is because we increment our index, so we have to this is the actual index. This is the index that is +1. Yeah,
Makes sense.
yeah. So and in here we know that we have our group, and I think we have to check if it is sorted. We still need I think because we need to know that our group that can be sorted to, for this example, that can be sorted to 1, 2, 4. So we need another information. We need another information that is we need another information that we have to we have to that we have to that the sorted group I equals to index, which means is that let's say we have another the target, and the target we can push back our target and just push this index, and we check if group the sorted group can be equals to target, equals to target I, right? So we can check let's say if not is send the group and the target, then we just return false. And otherwise, if at the end of loop we can return true. And we have to also to consider the duplicate the same index. So every index we push in here, we have to also to insert it then here, and in the for loop in the beginning of both loop, we have to check if the index I is used before, and we can the I -1. This is actual index. We insert the actual index. So if use dot contains I, we can just continue this index. Yeah, and the extend function. So can I assume that we have the extend function that can check if two vector is they are just the same vector.
Yeah. Okay. So it's saying basically it returns true if all the elements are the same in the same order, correct?
Yeah.
Okay. Yeah, it sounds good. Okay. So are you happy with this?
Sorry, can you repeat that again?
Yeah. Are you happy with this or?
I think I have to I think I have to dry run because maybe some typo or some logic that may be missing here, or the index transformation. I have to, maybe we can dry run.
I see. So I think it's pretty good. I'm not seeing any problems. Maybe we'll come back if we have time, but I want to make sure
Okay.
you have the time for the second problem. So let's just
Okay.
move on.
Okay.
So for the second problem, you have a puzzle, and I don't know if you've ever seen like these things in real life. So basically, you have this puzzle that I will represent tiles with numbers. So let's say we have something like this, and
Okay.
there's one tile that's missing. So in this example, so I'll represent the missing tile with a 0. So imagine there's like 6 tiles, and then there's a missing tile, and there's square tiles. And so this missing tile is basically a blank space to where you can take any of these tiles and shift it into this blank space. So like, for example, one move you can do is like, this stays the same. Just maybe this. Okay. So let's say one move you can do is you can move this. So basically what you did here is you took this tile and you shifted it into the blank space. Does that make sense?
Yeah.
Okay. Yeah. Another move you can do is like you can move the 5 into the blank space. So that would also be valid from the starting move. So that would just look like this, 5, 0. And then the third move you could do is you can move the 2 into the blank space, right? Because basically the only thing you can move is tiles next to the blank space into the blank space. So this would be like the other move. Does that make sense?
Yeah.
So essentially the only move you can make in the game is take a tile that isn't blank and move it into the blank space. And what I want to do is I want to have an end game state that looks like this. So, and anytime you take a tile and move it into the blank space, that counts as one move. And basically, I want you to return the min number of moves to win the game. So, just to give you an example, in this first one, it would just be one move because I can just take this 5 and move it into the blank space. Now, some of these are unsolvable. So if it's unsolvable, like an example like this is actually unsolvable. No, 3. If it's unsolvable, so you can just return whatever you want, like -1 or infinity or whatever here, and that's the case. So basically, yeah, that's the problem. Feel free to ask anything you want to.
Okay, so can I check again that what is the definition of win the game?
So win the game is you get to this state. So this is end state. So you need 1, 2, 3, 4, 5, 0. That's win the game.
Oh, okay. 1, 2, 3, 4, 5, 0. Okay. And okay, so let me check again. So we have a 2D 2D integer array, and so can I check that this the value are there any duplicate value, or they are?
No, so you will always have 1, 2, 3, 4, 5, 0. They will just be in different places at the start.
Okay, so for this example, there are 6 elements. So so we have 6 different values starting from 0, right? 0, 1, 2, 3, 4, 5, 6 value, right? So we have the 2D array, and the value is starting from 0 to like m minus m multiply m minus 1. And my target is to like my target is like it's like if this is a 1D array, if this is a 1D array, to like 1, 2, 3, 4, 5, and make 0 to the end of the last array, for example. Yeah,
yes.
for example. Yeah.
Yeah.
Okay.
So you will always have like, yes, it's n by -1 technically, but you will always have 6 tiles, and they will always be these tiles. The only difference is the starting locations.
Yeah. So okay. Yeah. So the tile is just 6 tile, or there are multiple, maybe 9 by 9 or
No.
10 by.
It's only this. It's only these exact tiles. The only
Okay.
difference is
So
there's the starting location can vary. So you will
okay.
always
So
get, it's always 6 tiles.
it's always 6 tile. Okay. So and the target is like 1, 2, 3, and 4, 5, 0. Yeah. And I have three operation, 3 swap operation, 3 swap operation. The first one is swap, like IR row column with swap. Let's say this is a grid, swap grid with grid -1 column. Maybe we have four operation, right? We
So
can.
you don't have 4. It depends on where the tile is. So let's take this example, okay? So this 0 is
Okay.
in the corner. The only tile you're allowed to swap is with the 0. So what I was basically saying is like these other tiles are an actual tile, and the 0, you can imagine it's like a blank tile, so these other tiles can go there. So if I
Okay.
take something and move it into the blank tile, now the blank tile is where this thing was. So in this case, I can only swap the 5 and the 0 or the 3 and the 0. So it's not 4, it depends on where the 0 is. If the 0
Yeah.
is here, for example, then there would
Yeah.
be 3 and so on,
Yeah.
right?
Yeah. Yeah.
So,
Okay. So
Yeah.
okay, because we can, that's also not out of bound, not out of not out of bound.
Mhm.
So there are, I think there are 4.
Yeah, so there's like 4 possible, but the only ones you can do
Yeah.
are where one of these is a 0.
Yeah.
Yeah.
So okay. So I can, 0 is like a blank blank cell. So any adjacent cell to the blank cell, we can swap them, right?
As long as it's right next to it. So I can't like put the 1 into the 0. It has to be right
Yeah.
next to it. Yeah.
Okay. The adjacent. Yeah.
Yeah,
Okay.
Jason. Yes.
Yeah. So minimum number of move to win this game, right? Can I ask that? Are there is there possible that we cannot win the game?
It is possible you can't win the game, yes. So I think I showed you one of like in this one you can't win the game.
Okay. Yeah. Okay.
Yes.
Okay. Yeah. So
So you can just return some arbitrary thing for that. Infinity, -1, whatever you want.
yeah. Okay. So I think maybe this question is a little bit like the previous question. What I mean is that we have that. Let's take this example. We have this is our input, and we know that our output is, we have a clear output, right? We have a clear output that is 1, 2, 3, 4, 5, 0. We have a clear output. So, and we have to move our blank cell with adjacent, and to make this value. I think we can focus on the blank cell, because the blank cell must be placed, must be swapped, or must be placed, swapped until it is in the last cell. And I think and let me copy the another case, and can the output is sent. So I think because this case cannot we cannot win this game in this case because let me try some swap.
Sure.
1 2. If 0 is 3 and 0 is here, and 5 4 5 4 3, and at okay, 5 4 0 1 2 3 1 2 3 4 5 0 1 2 3 4 5. Okay, so I have I think there is a property a property in if 0 if our blank cell is in the is in the corner, if it is in the corner, it can this can if the 0 is in the corner cell, it can only swap with two position, which means the order the 2D order the 2D order like a clockwise order no, not the clockwise uh 0 3 0 2 I think there is a fast solution, a fast way that can check, efficient way that can check, but I cannot figure out this, and
Yeah,
I
so
think
I
I can
would,
try.
to give you a hint, I would not try to come up with some crazy optimization. I would do it more in like a coding way because it's like a pretty
Yeah,
small puzzle. So like, how would you? Yeah.
yeah, okay. It's a small puzzle. Yeah.
Yeah, I'm not looking for some like optimization of like you can
Yeah,
figure out
yeah.
some best way to do it. More just like how can you code a way to figure out how to do it?
Yeah. Okay. So I think the idea in my mind is that I can like try out every possible state.
Okay.
Like we have a DFS, the DFS approach
Mhm.
to go through each possible view, each possible state. We can, because we only have six cell, we can like the state, we can format like the state is like A0, A1, A2, A3, A4, A5. We can just write this, and in our DFS approach, we can like swap, try out every possible swap, and if we go through the same state, we can just return. So I know, because we need a minimum number of move, right? So we can use like a BFS, the BFS approach, because it's like a graph. We have we can think like this is a node, as a node. We have a node 0, and we have node 1. We can build another node 1, another node 2, and node 1 can build another like node 1 1, and then for example, and if we use BF approach with like another hash set, BFS plus hash set, and we can guarantee that we will not encounter this same, we will not count the same state multiple times.
Cool.
So that
So
the
one
end,
quick question for you. So you use a hash set. How will you represent this state in your hash set?
yeah, I think I will format this as a basically I think it's a string,
Okay.
like unordinary set as a string,
Mhm.
right? And I think we can also use an integer because the value is really small, so it's like a bit. The phi is 0 to 0 101, right? So we
Yeah.
can give each bit each value 3 bits. So total bit is 3 multiplied 6. We only need 18 bits. So an integer can afford this. Yeah, yeah, I think, yeah.
Okay, yeah, I'm not super concerned with that. Whatever way you want to hash it, totally fine. String, bit, whatever's easier for you, works for me. So, last question: what's the time and space complexity of this?
Yeah, the time the time complex. I think it's like we have the one, two, we have in, let's say we have in 1D array.
Mhm.
We have a 1D array, and we know it's a permutation, like a 6 factorial of 6,
Mhm.
and multiply every BFS we have. I think it's just the time is the big of n. Let's say we have n by n.
Mhm.
Let's say we have row size multiply column size,
Mhm.
the factorial of row size multiply column size, and the space is bigger of if we, let's say we use the string, so it's like maybe we have row size minus this. How many numbers then we, yeah, for example 6 number, we there's the 6 character, no, it's just the because we are using the BFS, and I think the space complexity should be like should depends on, we have the tree, right? We have the tree.
Mhm.
We have the tree. We have the tree. Maybe we have another node.
Mhm.
We have at the most three operation, right? And at some node we have 2 operation.
Mhm.
So because we are sorry, because we use the BFS approach. So the space complexity, I think it depends on the level, the level of the tree, right? And the exact uh, the exact the exact value, I'm not sure the exact value
Cool.
here.
Okay, that sounds good. I think this is good enough. Let's move on to executing it. So let's write a solution.
Okay. So can I code now? Yeah,
Yeah.
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 Okay, okay. Okay, let me try.
Sure.
So should I declare or send a function?
Yeah, just make a function. You can take a 2D array, you can take a 1D array, whatever is easiest for you to work with. I don't really care.
Okay, okay. So let's say we have the minimum operation.
Okay.
Minimum operation to win the game. This is our function name,
Mhm.
and we have the 2D. Let's say we have 2D array.
Okay.
2D array, and we call this grid, and we have to return the minimum number operation. And since we are using the BFS, so I think we need unordered set that is let's say we use this string. We call this used. And we need the column size. Let me define the column size and row size here. Row size is equal to greet size, and the column size is equal to greet 0 size here. And we need a queue. We need a queue that needs to store our string. Right. So the string is like this is like the greet 0 0 and the greet 0 1 and greet 0 0 2 and like this. And I think we don't need this mark because the value is just a single digit, right? We will not have a 11 value that
makes sense.
And we can push our let's say we have a helper function that make key. We can make our greet, the current greet, to the key and push it to our queue. And the initial state, we can also make key and here.
Yeah, and I think you don't have to write make key. I'm pretty sure you know how that works, so we can just pretend it exists.
Yeah, okay, thank you. And while now queue is not empty, and here. So I think we will check if it is possible. We reach the end state, then we will return true. Otherwise, the queue is empty. We can just maybe return like the -1 here, and we need the end state. So the end state is like 1. Sorry, let me check. 1 2 3 1 2 3 4 5 0 1 2 3 4 5 sorry 1 2 3 4 5 0. This is our end state. Is a string type. string is a string type, and we also need another operation. We call let's say we call operations equals to 0, right? And at each BFS, we will increase our operation at the end here. So because the BFS I'm writing now is like a level order BFS. So we have to know the queue size. So the size equals to queue the size. While size bigger than 0, we can decrease our size here. So this guarantees that all the level of this queue will be popped out and to the next level. For example, here, the first and the second and the third level here.
Yep, got it.
Yeah, okay. So at each level, we just get our current state equals to queue.front, and we can pop this from our queue, and here we have our current state, and we have to try our swap operation. Here we have to try our swap operation, and before we try our swap up, we have to check if this current state equals to end state. If that is the case, we can return our operations here. For example, if the initial state is equal to end state, and here we will return, and initially this is 0, so we need 0 operation if the input is the same as the end state here. So yeah, so let's try our swap operation. So for this, I think we can have I think like I will I will try out 4 in the line 130. I will try out this 4 swap operation, and to make sure that it is not out of bound. If it is not out of bound, I will push this state. If it is not out of bound and it is not visited before, I will push this state to our queue. So to do this more clearly, I think we can define like a direction array. TIREC directions. Let me say it's 0, 1 and 1, 0. Oh, sorry, the definition 0, 1, 1, 0 and 0, negative 1 and negative 1, 0. Here we have a direction array here, so we can check from we have just 4, right? And we have to swap swap with the sorry we okay, we have to find sorry let me copy this input here. And here we have to
you can pretend you have a function called like get key that takes a string and gives you back a grid, if that helps.
Okay. Get key.
Or get,
okay.
I guess it wouldn't be get key, it would be like get grid or something. But you can take a string and get back a grid, if that helps.
Okay. So yeah, this will help. Let's say we have a helper function that can help me find the index, the 0, the position of 0.
Sure, that's fine.
Right. Yeah. So let's say the auto. Let's say we have the index because our state is just a because our state is a string, and
you can also find that yourself. But yeah, I was saying you can have a function that takes a string and gives you a grid, so you can have the grid to work with, right?
Yeah. Okay.
Yeah.
So yeah, okay. This will help. So new grid equals to let's say Mac grid, and
you can pass a string to it or something.
Yeah, we just pass our current state and the next direction that we have to swap. Directions I.
That's fine.
Directions direction I0. Let's say direction I0 and direction I1 here. Yeah, and the new key new state make state or make key. Let's say we had we rename this to make state. State. Yeah, make state our new grid here, and we can check if this is visited. This is not visited. We can just push this to our queue. So if use dot contains new state, if not use dot contains new state, we can just push the new state TAT here, and also insert this to our user array. Yeah. I think check again. I think this should be work conceptually.
Yeah, I think I agree as well. So let's just stop here because we're already like 15 minutes over. So let's do feedback.
Yeah. I took too much time. Yeah.
Okay. So what do you think you did well, and then what do you think you can improve in?
I think I can. I think the well part that I did is like when you give me the hint, I can think like I can take the hint in the I can take the hint and I can like describe my thought and what I think I did not really good at like I didn't in the first question I didn't I was stuck in the initial thinking, and I think I should write out more, like write out more sentence to sync with my thought and sync with the interviewer thought,
Mm-hmm.
so that the interviewer will know what I'm saying now because I think I'm saying too many too many too many things that just I know, but the interviewer may is not thinking with me at
Mm-hmm.
that time. I think, yeah.
Okay. Yeah. So I think for the first one, you restated the problem. You asked about the constraints. You mentioned you can make these groups and sort. I think it took you a while. I think you were trying to do some sort, but you had a lot of trouble like simplifying this problem to like a solution. So I think in both of these, one of the main areas I think you have to work on is like speed. So take a problem, get a solution that's like, without coding, but actually come up with it like faster because you spent a lot of time kind of like stuck. Um,
Yeah, yeah,
like you had a bunch of things you were like, okay, I'll have this like sorted and I'll have this index and I'll have all these other things and I'll have these like groups. Eventually you came up with the groups and then that was fine. And then the other thing is this would have been like really good if you knew it. So I guess, yeah, so do you know? So if sorting an array takes n log n and I split the array up into groups and I sort all the groups, what's the upper bound on the time complexity of that?
yeah. It's the upper bound, right?
Yeah, like what's the worst it could be?
Yeah. The worst case is like every index like one, two, four. We have each group have the every index, and the smallest group is starting from the group one. So it's just we have log 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 n, right? Uh,
No, no,
yeah,
I
one.
mean, what's the total? So like splitting into groups and sorting each group, all of that combined. What's the slowest that can be? Like all total, not for one group.
O total. Okay, the O total.
Hmm.
Yeah, we have to sort group one, group two, group three, right?
Hmm.
And by sorting the group one is like a log, it's a log something,
Hmm.
let's say log G1,
Hmm.
and log two, log two, log G2,
Hmm.
and log two, log G3, and
Yeah.
right, yeah, and the last part log G, let's say Gn
Hmm.
here, and and I think mm, I'm not sure on maybe it's like
Yeah, so I guess
maybe
I can tell you. So basically, like sorting an array is n log n, right? These
yeah, yeah,
groups are all smaller than n. So if I do like
yeah,
G1, G2, and so on, right?
yeah,
All of these G's add up to n, and all of these logs add up to n. So this has
yeah,
to be smaller or equal to n log n. So I think when
yeah,
you explained it, you like didn't understand that, and that would have been like a nice thing to know. It's like if I have
yeah,
an array and
okay,
I split into groups and I sort the groups, the upper bound is you only have one group. If you split it into more groups, because each group is smaller, the sorts are faster, and all of it combined is n anyway. So
yeah,
so it would have been good for you to like understand that. But I think that's like okay. Um, and yeah, the main thing was like you were kind of like stuck a little bit, and yeah, ideally you could do this faster because I think like I said we went like 15 minutes over, and I was like pretend you have these functions that like probably isn't going to happen in a real interview, right? Because I was more concerned with like, can you do the part that I care about? Like, I don't really care if you can make a key into a array or like that stuff is like, I know you can do that and it's not really important.
Yeah. Okay.
So definitely try to come up with a solution faster. And then I think a lot of you also went into, so I think you said there's a lot of things in my head that I talk about, but the interviewer might not be on the same page. I kind of felt it was the opposite, where you went into details in a lot of things that I thought was obvious.
Oh.
And then you were like
Okay.
explaining it in more detail. Like you were like, oh, I'll have these groups, and then I'll like I didn't write down exact things, but basically you went into detail on a lot of things, where like an unordered set and like how you'd make sure you wouldn't visit stuff over and over. It's like if I'm asking you this problem, I'm probably familiar with how the problem works. So you don't need to go into like crazy detail of like everything you're doing, because there's probably like 2 or 3 ways to do it, and you can assume that I know them pretty well.
Yeah. Okay.
So you don't want to waste too much time going into like too low level details of like stuff that I would consider kind of like obvious, like how a set works, how you make sure not to revisit stuff, all that kind of stuff. So I would try to keep things high level. Maybe you can ask like, do you understand? Do you want me to go into more detail? And then do that. But if you go into too low level detail and too many items and have examples of everything you do, it just takes a lot of time.
Yeah. Okay. Yeah.
And so there were a
Yeah.
lot of points where you were saying stuff, and I was like, why? Like, I already knew what you were gonna say like 2 words into it, and I'm like, all right, I guess I'll just let you say it. But like, you didn't tell me anything I didn't know. So, does that make sense?
Yeah. That makes sense. Yeah. I think yeah. I will take too detail. Yeah. That may
Yeah. So just like
waste a lot of time. Yeah.
yeah. So anything you say, make sure it actually adds like value or like clarifies things for me, not just like really obvious stuff. Okay, so I really like that your code was pretty good. Like, I feel like you were thinking about things slowly, but like when you took your time and you coded, it was pretty good. Your ideas were pretty good, and you like I think you had a very good thought process. It just needs to get like sped up. So it's like do everything you're doing, just do it like twice as fast or 1.5 times faster, whatever. But I think I really like the problem solving, the breaking stuff down, and all that stuff for the first one. And yeah, I was like, we're like 10 minutes over or something after the first problem. So if I let you dry run, we're going to be like a billion years over. So you basically just need to be able to get this faster.
Yeah.
I think the group thing makes sense. I think there's a few solutions. You can do a group. You can also just for every value, you can check like where it should be. And then there's like a math solution where essentially it's like if I'm at index 4, I need to be at index 2. Basically from wherever I am, you kind of were doing this like on line 45. So basically the way to check if something is valid is you just need to take like the bigger one, divide by the smaller. It needs to be like actually divisible, and then that difference needs to be just like 2 to the end. So there's like a math solution as well, which is like totally fine. But I think your solution makes sense as well. I think you were like trying to think of this, but then you like struggled, and then you were like trying to figure out the right things, and you're like, I'll just make groups and that'll be easier. So either one's fine. Just make sure whatever solution you come up with is like pretty easy to code and you can do pretty quickly. So if it's complicated, like if there's multiple solutions and you know one of them is going to be complicated, go for the easier one that you can just like do as quick as you can.
Yeah.
Okay.
Yeah. This helps. Yeah.
Yeah. And then yeah, so I basically gave you like 4 out of 5 for DSA, 3 out of 5 for communication, because you were like basically oversharing, coding 4 out of 5 as well. And then speed 2 out of 5. I thought that was like the main thing, because realistically in an interview, like if we have till X amount of time, if you don't finish, I'm just going to be like, all right, we're done. No, even if everything you're doing is very good, right? I'm not just going to be like, all right, I'll give you 15 more minutes just because I like what you're doing or whatever, So
Yeah.
okay. For the second one, let's see. Wait. Okay. Yeah. So for the second one, you asked about everything as well. Same kind of thing. Like you want to understand the problem a little bit quicker. You understood that you can do a DFS, and you were like, oh wait, I can actually just do a BFS, and because that'll give me the minimum amount of time to get to the end state. So that was good. And I thought your problem solving approach is pretty good. You were basically like, okay, I'm going to find the 0, and I'm going to do these 4 swaps. Whatever's actually in bounds makes total sense. You figured out how you could store the key. I liked that you knew how to do the bit thing. I'd probably not expect that. I think most people don't know that, but it shows that like you do low level and you know how to store stuff in like small memory amount if you need to. Then yeah, you didn't understand the space complexity. So for the BFS, I think you wrote. Where did you write it? Here. So basically, the time complexity is this, right? And for the BFS, like you're storing every key in a visited set. So every key is like, you can basically think of it as like constant space because it's only 6, but you basically have the same thing. You have the row call factorial in the visited set. So they should have been this for the space as well. Does that make sense?
Yeah.
Okay.
Yeah.
Then yeah, so because for both of them you were kind of a little bit off on time and space, I would definitely review time and space for more complicated problems, just so you don't have these like issues. Like you kind of get it, but if it gets a little complicated, I feel like you struggle.
Yeah.
And then yeah, so you talked about what you're writing again, same kind of thing. You were oversharing, and because of that, I was like, okay, well, we're like super low, like we're way over. I'm just gonna say some of these things that are pretty obvious that do exist in a real thing. It would have been good to see that, like, maybe you made a function that made a key, maybe you made a function that made a grid, make some of these things and use them. Because in reality, people probably aren't going to be like, let's pretend these things exist. So you would need like a fully working solution. And then, yeah, so I'd say your DSA and problem solving was pretty good. Your communication was okay. Once again, the oversharing, your coding was pretty good. And the other thing that you do that can help you is you can plan out the complicated parts of your code. If you like, if you get a solution, if you're like, oh, this is BFS and I know I can store a key, then you can figure out, okay, what are the complicated parts of my solution? Well, probably the only complicated part is like find the 0 and then do the swaps. So then you just have to figure out, like, what does that look like in code? Maybe have a few lines of pseudocode. Because whenever you got to the coding parts, you were like, oh, I need this, oh, I need this, oh, I need this. And you didn't really discuss any of it before you coded. So as the algorithms get harder, if you just say, like, if you go too high level in your approach, then the person's going to be like, fine, but then there's going to be like too many things in the code that are going to be too hard for you to keep track of. So I would definitely recommend, like, judge the difficulty algorithm yourself. And if you think it's reasonably complicated, figure out, like, what are the difficult parts and, like, what does that look like high level. And then when I do the code, I know what it looks like. Because a lot of people will be like, oh, this is like Dijkstra's with whatever. And then they go and code and they're like, oh, so what do I need? I need like a heap. I need this. I need like, there's too many things. And then they get lost. So that just depends on you. If you can figure this out all as you code, fine. But if not, I would definitely recommend planning out some of your algorithm, and don't go too high level in what you're talking about, because you might struggle with implementation and it might actually take you longer, because you will have to think about, like, what do I need and what does this look like and what is this again? This is confusing, that type of stuff. So I would just like trade off, like, yeah, basically how much to plan ahead and then how much to actually do in your coding. Does that make sense?
Yeah. So for example, like I give the high level, and I have to think the most complex part in my code and describe the sort here, so that when I implement this part, I will not stuck.
Exactly. So basically what I would say is, like, maybe, so just to give an example, let's say I have some key, right? 1, 2, 3, 4, 5, 6. I'm going to have a function that will take a key, turn into a matrix. Something like this, right? Whatever. Can't type. Okay, so let's say I'll turn it into a matrix. Then I will need to find the location of the 0. So maybe I can iterate through my matrix, get the row and the column for the 0. And then basically for every dir in directions, try to swap. And then rebuild the key, right? And then this will be like good enough for you, right? This is like pretty simple of like, what are the parts I need to do? I need to take a key and I need to turn it into a matrix. I need to get the matrix, find the location 0. I need to go through every single direction and swap the 0 with that, and then I need to rebuild the key. So now it's like very clear of like, and this is like the only really hard part of the algorithm. The rest of it is like pretty straightforward, right? It's just like a BFS prop from a BFS, and that's it. So that's what I would try to do, is like figure out what's the part that I might have trouble with, write a few lines of text, and make sure you understand how this will work. So maybe walk through a quick example with that. The other thing is, there are some algorithms that you'll get some problems that, like, you're not going to be super confident that your algorithm works. I think for these, it was like pretty clear, but some of them you might not know if it works, and you might not have a lot of confidence. So for those, I would recommend writing down these steps and then dry running those steps with whatever example you got, and be like, okay, so I'm going to try these steps with this example. Does this work? And sometimes you'll find, like, actually this needed to be, maybe this or whatever, right? Or whatever. And then that way, once you get to the coding, you know 100% that like what you are planning is going to work. Does that make sense?
Yeah, that this helps. Yeah.
So I think the faster you can get to a high level solution, like I'm going to do a BFS, the faster you can get to planning out the approach in high level, the faster you can know this is all going to work, and then the faster you can get to the coding. So it's all kind of a snowballing thing, right? Like if you take longer on one part, then you're like then you're running low on time in another part, and then you just end up doing worse because you're like, I have this amount of time for this interview and I spent way too much time on this one part, so that screwed me up everywhere else.
Yeah.
Okay. Yeah, so I mean, I would say this would be like a lean higher for me, but honestly, I don't think you should really care about that. I think the goal for mock should be like you said, don't be nervous. Like, do enough so where you're not nervous in the actual interview. However many that takes, do that. And then try to get a strong hire in the mocks, because that way when you do the real interviews, it's not like a 50-50. You have very high confidence that you're gonna do well.
Okay. Yeah.
Okay.
And
Okay,
can I ask that how can I avoid my oversharing? Because when I interview before, I encountered an interviewer that doesn't know what I'm saying.
Mm-hmm.
So I just think maybe I have to explain a lot of details so that maybe like so I think I do too many details. So I would like to know.
Yeah.
Yeah.
So I see what you're saying. So basically, you were like, I didn't share enough, and then they were stuck. So one thing you could do is you could explain everything you're doing, and then have like checkpoints. So you can explain something and be like, "Is this good, or do you want me to go into more details anywhere?"
Yeah.
And then that way
Yeah.
you get consensus from them, and you
Oh.
can move on. You will get some interviewers that ask, like it happens, like they'll ask a question they probably haven't really asked ever, or don't know the stuff well, and like maybe you could argue they're not even qualified to interview. That does happen, right? Like, maybe it's like someone's first interview for a company. They ask a question they don't really know, all that kind of stuff. It does happen. Maybe they'll like hint you towards an approach that doesn't work. Also happens. You get some like bad luck. But in general, I would try to think like, okay, like what are the things I need to share, and what's to, or maybe just like let's say I'm using a visited set, you don't have to go too low level. You could say like, so I'm using a visited set to track duplicate states. I'll store the state. You don't have to be like, oh, and here's an example of me putting a state in here, and then when I run into the state again, it'll be in my set or something. Like it's fair to say that if you use a set, someone knows how a set works, or things like that. So basically, everything you use, be like how much level of detail do I need to go into, or can I assume they know these things? And so yeah, I usually try to do the checkpoint thing where every time you do a section, you just say like, are we good with this part, or do you want me to explain anything in more detail? And then if they say they're good, then they're good, and if they're not, then you can go into more detail.
Yeah.
Also, obviously, this is more for like meta or something where like it's a super time crunch. If you have 45 minutes to do one problem, I would definitely slow down, take my time, and explain the stuff in more detail, right? So it definitely depends on how fast you have to do stuff and how competitive it is and all that stuff.
Yeah.
So
yeah. This helps a lot. Yeah.
Okay.
So yeah, can I ask another question?
Yeah.
About do you think my English is not communicate with you? I mean, I think my English is not really well, right?
So I think obviously if you had better English, you could communicate faster. But I never had a point of like, I don't understand what you're saying because your English isn't good enough, right? You have to speak slower because you probably have to think about it more. But I could totally understand what you were saying. Like, I think it was fine. Like, I had managers that had worse English than you, and I could totally understand exactly what they were saying. Like, no problem. So,
Okay.
So I don't think people are going to be like, your English isn't good enough for me to understand what you're saying. For sure.
Okay. So can I make a conclusion that maybe when I encounter a question, just like give a high level a high level sort, and plus and find the complex part
Mm-hmm.
to try to like a dry run
Mm-hmm.
and figure out the implementation
Mm-hmm.
and always make a checkpoint with interviewer to avoid the oversharing.
Mm-hmm.
Right. Maybe. Yeah, I
I
think.
mean, that would totally depend on the amount of time you have. Like I said, if you have 45 minutes for one of these, overshare all you want. There's no downside. But if it's like 20 minutes for each and you spend too much time doing these things, it's really going to cost you.
Okay. Yeah.
Yeah.
Yeah. Yeah. This makes sense. Yeah. Okay.
Yeah. And I think it's actually kind of very similar to like the AI coding now, where nowadays you spend a lot of time planning stuff out and you're like super confident that it works. So basically, ideally, once you get to the part that you're coding, you should be as high confidence as you possibly can that your code is going to work. Ideally, like obviously maybe it's not always 100%, but you want to be like, I know exactly what I'm doing. I'm just writing the code, and I know like my algorithm and my level thing works 100%. Because the worst thing that can happen is you write it and then you're like, oh crap, I forgot something. This algorithm doesn't work. I got to rewrite it, because that's like instant fail.
Yeah. Yeah. Okay.
Okay.
So
Cool.
yeah.
Anything else?
Do you think that the interview like this type of DSA coding interview will be like because of the AI, this kind of coding DSA interview will be removed or will be deleted to the like system design interview? Or do you think?
I honestly have no idea if they're going to remove coding or what. And also, I do think as long as you're not like memorizing tagged, I think DSA interviews translate fine into other types like practical or whatever. It's still all the same thought process, right? You get a problem, you try to figure out a solution, you plan it out, you code well. So I don't know what I don't know for from my experience interviewing last year, every single company I interviewed for asked LeetCode or something similar. So I don't know. Like I can't. I'm not a. I don't know the future. But
Yeah.
like I said, I interviewed like 6 months ago or something. So, and every company has
Yeah.
LeetCode. So
Okay. Yeah. Yeah. This helps a lot. Yeah. Thank you.
okay,
Yeah.
sure. All right, cool. See ya.
Yeah. And then thank you very much for interviewing with me. I think it's a really great interview and your advice is really, really good. And I think this will help me. And thanks for your time. Yeah.
Yeah, for sure. If you have any other questions, you can just write in the Discord.
Okay. Yeah.
Okay. See ya.
Yeah. Thank you.